Throughout this goal, it is helpful to have a periodic table available. So get one out that you can look at while you're watching the video. Let's talk about the historical development and organization of the periodic table. So we go back to 300 BC to Aristotle, and he said that all matter is made up of four elements: earth, air, fire, and water. And there's just a little funny Aristotle's periodic table, what it might have looked like. His ideas persisted 2,000 years. And then fast forward to and he was able to
Lavoisier,
make a list
and
of
he
300
is the one
elements.
that's
So pictured over there to the right with his wife Marie. And he was the one that he took very careful measurements, and he came up with the law of conservation of mass. And he looked at the elements that were known. He was able to make a list of 33 elements, kind of the start of trying to organize the what type of elements and matter is out there. And Lavoisier, he did careful studies also and discovered the difference between metals and nonmetals. Sometime later, Dobereiner in 1829, he noticed that some groups of elements, they had similar reactivities. And so we see here in the very first column, he was able to put lithium, sodium, and potassium in a little group, and he called these groups triads. And then in the second column, we have calcium, strontium, and barium. And he noticed that these little groups of three, that they had similar reactivities. Now, Dobereiner didn't know about the periodic table, so here we've put his ideas on a modern periodic table. But just so you know that these triads, he was correct that these groups of three, they had similar reactions. And so again, what we're trying to do is just to organize the matter that's out there. So Mendeleev, he was a Russian, and in 1869, he took the known elements and he put them on little note cards, and he dealt out and sorted these cards, and he put the elements into varied row lengths of 7 or 17, and he left blank spots, and that's what gave him credibility. Is he said that there's a blank spot here, there's an element that hasn't been discovered yet, it should have this such and such melting point, it will have such and such properties. And then he published this. So very brave to do this. And scientists, when they read his paper, they said, well, he says there's an element, let's go find it. And they were actually able to find this element that hadn't been discovered. So this gave credibility to his ideas here. And he organized his periodic table according to the masses. So how heavy they were or how light they were. William Ramsay in 1894, he discovered a whole group of gases, and these were called noble gases. And noble meaning like royalty doesn't associate with the riffraff peasant class. That's what these noble gases were. They used to be called the inert gases because they thought they didn't react with anything, but we have discovered that we can make them react with some super reactive elements such as fluorine. And so they are now called noble gases. And William Ramsay received the Nobel Prize in 1904 for this discovery. And they were difficult to discover because they, again, don't react. Um, so this was a whole family that was added on to Mendeleev's table. So now we come to the British scientist Henry Moseley in 1913, and he took x-rays and he shot them at crystals of the elements, and through the diffraction pattern that was formed, and a lot of math, he was able to predict what the atomic number of each of the elements was. So we're talking about the number of protons. And so he took Mendeleev's periodic table and he modified it. And he said the periodic property is that elements are, shoot. Moseley, he modified the periodic law, and he said that the elements are arranged according to their atomic numbers. So our modern periodic table has elements organized in periods and groups or families. So a period is a row of elements, and if you look at your periodic table, there are 7 rows. And then there are groups. These are columns of elements, and they are known to have similar properties. And also, I will refer to them as families. That's just a group or a family is the same thing. You might wonder about the 2 rows of elements at the bottom. If you look at the numbering system, you'll find that those elements are actually just cut out of the periodic table. So the periodic table really should be double in the length, but for printing purposes, they have cut out some of the elements and put them on the bottom. So when you look at the periodic table is, according to Henry Moseley, arranged according to atomic number, the number of protons. So looking at the periodic table that was given to you at the beginning of the year, you can see that the columns or the families, they can be numbered between 1 and 18. So this is just a way to communicate what family or what column that we're talking about. Now on your periodic table, I really like this periodic table and I purchase it because it has so much good information. But one thing that they don't do right is they don't number with the Roman numerals correctly. So you need to stop the video and compare your periodic table to this one. So what you're going to have to do is you're going to have to make sure that all of these, they end in B, and all of these on either side end in A. So you're going to have to change some of these from B's to A's and A's to B's. So go ahead and again stop the video and make sure that yours matches. Okay, we're back. So those Roman numerals, they have stopped teaching Roman numerals in the elementary schools. And so let's just kind of go through a little tutorial for Roman numeral. So the Roman numerals is kind of a tally system of, it's a way to represent a number. And sometimes people don't use the Roman numeral system. Instead, they will just write out the normal number. But let's just kind of go through how to do Roman numerals. So for Roman numeral 1, we can just write a 1. If you want to make it fancy, then you can give it the little top hat and the little feet there. For 2, it's a double tally. And if you want to make it really, really fancy, again, do the top and the bottom. 3, it's a tally of 3. Okay, so it looks like that. Let's go ahead and skip to 5. For 5, it's a V. And you can leave it just as a V, or if you want to be fancy, you can go like that. Let's go back to 4. So 4 is actually represented as 5 minus 1. So it's written as the V and then a 1 before. So it means 5 minus 1. So that's how we get the 4. Now we have 6. So we have 5, and then I'll put 2 ones. And then 7 will be the V and 1, 2. Oh, I did 6 wrong. Let me go back. I'm sorry. So 5 and a 1, so it's 5 plus 1. And then a 7 is a 5 and 2. Okay. And then let's do 8. So 8 would be a 5 and 1, 2, 3. So notice you don't have to put the little top hats on them. You can if you like that style, but this is certainly acceptable. Let's go ahead and skip 9 and go to 10. So for 10, Roman numeral 10 is an X. And go back to 9. So just like we did with a 4, how a 4 is 5 minus 1, for a 9 we do 10 minus 1. So it's a 1 and then an X. So these are Roman numerals. So as you can see right here, these 3 columns here are known as 8B. And sometimes you do see it written as 8, the numeral 8, or you also could see it as the V111. Okay, so again, make sure that you have changed those numbers on your periodic table so we're all on the same page. So again, the columns can be numbered 1 through 18, or we can have the main group elements always end in A, and then we have the elements that are in that little valley always end in B. The families of elements. So I've written the name across the whole column, but maybe you just want to write the family on the very, very top of your paper. And you do have a paper in your packet that is a blank periodic table that you can kind of fill in, but still don't write across the whole column, just write at the very, very top, like right here. These are alkaline, earth, That's the alkaline earth family, okay? So we have the first column, to go back, we have the alkali metal family. And hydrogen doesn't have a family, so it's kind of an orphan, but it is stuck over the alkali metal family. But hydrogen is not a metal, so that's why I have it there in white. So it's just kind of hanging out. That's its adopted family, okay? The second one, this is the alkaline earth metal family. The elements that are in that valley, those are your transition metal family. And then we start naming the family by the first member. So the very, very top right here, this is the boron family. Then we have the carbon family, the nitrogen family, the oxygen family, and then we're back to the naming system. So you do need to know the family that starts with fluorine. That is the halogen family. And the last family, the one that William Ramsay discovered, that was the noble gas family. So these two rows here at the bottom, these are called the rare earth metals. And again, they are cut out of the periodic table just to make printing easier. But this has a name by the row. So, and it's named after the first member of the family. So the first row there, those are the lanthanide series. Sometimes they're called the lanthanoids. And then the bottom one, those are the actinides or the actinoids. So I think the more actinoids and actinoids is more kind of a older name. So lanthanides and actinides. All right, also on the periodic table, there is a little stair step dividing line. So it starts with boron and it steps down the periodic table and it separates the nonmetals from the metals. So these are all metals and these are all nonmetals. Okay. Now the ones that are in purple, those are the ones that they're kind of metals and they're kind of nonmetals, and we call those the metalloids. So I call them the tweeners. They can't decide if they're a metal or non-metal. So they might be shiny like a metal, but very brittle like a non-metal. Also, on your periodic table, you can see solid is always written in black. Liquid is written, the symbol of the element is written in blue. And a gas is written in red. And so this is the state of matter when we are at 25 degrees Celsius or room temperature. What do the man-made elements, what do their symbols look like? You're right, they will be an outline. So tectinium is a man-made element and it will be just the highlighted. And you can see some of the actinides, those are man-made, and you'll see that they are just the outlined is what I meant, the outlined letters. All right, there's our metals, nonmetals, and metalloids. All right, so as practice, go ahead and stop the video and see if you can complete this. Okay, we're back now, so we need to classify each as a metal, nonmetal, or metalloid. Aluminum, I forgot to mention, aluminum is so metallic, so even though it shares that border with the other metalloids, it is classified as a metal. So sorry, I forgot to mention that before. Sodium is a metal. Oxygen is a nonmetal. Silicon is a metalloid, so I'll just end it in a D. And neon is a nonmetal. And uranium, there at the bottom of your periodic table, it is a metal. Okay. Name the family for each of these above. So we have aluminum is in the boron family, sodium is an alkali metal, oxygen is in the oxygen family, silicon is in the carbon family, Ne is a noble gas, and U is an actinide.